Hello, and welcome to Aquatic Science Adventures, where we show you fun, educational, and easy aquatic science experiments you can do at home. If you have a child stuck at home during this period of social distancing, we know that it can be difficult to find activities that are engaging, educational, and practical for your young scientist. But we can help. My name is Katrina, and I am the camp administrator for the Aquatic Science Adventure Camp at Texas State University's Edwards Aquifer Research and Data Center. And I am excited to present Action in Aquifers. Today, from my own backyard, I'm going to show you how to make a model primitive water filter to physically remove larger particles like mud and sand from your water. Then we will use our model to learn about what happens when water flows underground through aquifers. It is important to note that the filters you will create today are not efficient enough to make water safe to drink. To make your water safe for consumption requires additional steps like smaller filter systems or diverse sterilization or purification methods. All around the world, people treat their drinking water in many different ways, from boiling water and water purification tablets to personal filter straws and even huge municipal water treatment facilities. In this video, we are going to make our own simple water filtration system and learn how it is similar to and how it differs from natural aquifers. You can use this activity to introduce key hydrology concepts like aquifer. An aquifer is any permeable rock or sediment containing or conducting groundwater. This is a map of aquifers in the United States. Turbidity. Turbidity is when water is cloudy or opaque because of suspended particles like mud. Purification. Purification is a process that makes water safer for drinking. This may include filtration, but it can also include many other processes. Filtration. Filtration is a process by which particles in water are retained and removed from the water as it passes through a physical filter. For this activity, you will need sand, pebbles, as many as 2 plastic water bottles, a small piece of paper towel or coffee filter, water full of dirt, mud, or rock, or you can use pantry items such as rice, couscous, flour, or even food coloring as your contaminants. You will also need gloves, scissors, a cup to collect your filtered water, and a sifter, which is optional and only necessary for separating smaller particles of sand. Let's get started. We will be making 2 separate aquifer filters to help illustrate how different aquifers operate beneath our feet. Our first filter will be made of pebbles. Our second filter will be made of sand. The first step to assembling our filters is to cut off the base of our water bottles. Parental supervision is advised when cutting the plastic bottles. I like these larger bottles so I can cut them in half and use the bottom half as my collection cup. Let's make our dirty water to pour through the filter of our first experiment. This process will be repeated in our second experiment. To make dirty water, I will be using water from the hose in my backyard and mixing in garden dirt, sand, clay, and rock. Be sure to give it a good stir to make sure it's as dirty as possible. Remember, hydrologists call this dirty water turbidity, when water is cloudy or opaque because of suspended particles. Realize that other untreated water may also contain microbes, insect eggs, larvae, other small invertebrates, or even toxic chemicals like arsenic. For our first experiment, we will make an aquifer filled with only pebbles. First, we will take one of our pre-cut bottles and turn it upside down so the mouth is pointed down into the bottom half of the bottle. Next, fill in the top half of the bottle with your pebbles. Now, observe your system and make some predictions about how well you think the filter will work. Then have fun testing your personal aquifer system by pouring in your pre-made turbid water. Pause the video while you complete experiment number 1. How well did your filter work? Probably not very well, huh? This pebble aquifer works like a type of aquifer known as a karst aquifer, where water flows quickly through big pores and conduits like underwater caves. You can visualize this concept when thinking about a block of Swiss cheese, or more accurately, this rock. The spaces made in a real-life karst aquifer are kind of like the spaces in between the pebbles in your model aquifer. Most karst aquifers are not very effective filters. Water goes through the spaces so fast because the spaces are so large, which means there is little opportunity for the aquifers to filter unwanted sediments or other contaminants. This is why karst springs can sometimes run muddy after heavy rainfall, and why it is generally a bad idea to drink from karst springs, even if the water appears to be clear. For experiment number 2, we will fill our model aquifer with sand to compare a sand aquifer to the karst aquifer that we saw in experiment 1. First, we take our second pre-cut bottle and our small paper towel or coffee filter square, and we place it inside the bottle until it rests evenly over the smaller opening where the cap is located. This will prevent our sands from washing out of the mouth of the bottle while allowing water to pass through. Once we have completed our sand aquifer model, consider how it will compare to the karst aquifer model in experiment 1. Will the water be clearer or dirtier? Will it flow through faster or slower? Pause the video while you make some predictions, remake your dirty water, and pour it through your sand filter. How did it go? I bet it worked a lot better. Flow through sand aquifers can be a lot slower than karst aquifers, and because the voids are so much smaller, a lot more particles get filtered out. But remember, this is still just physical filtration, so tiny particles like some microbes are still going through your filter. You definitely would not want to drink water coming through this filter. The aquifer systems discussed and illustrated in this video are important to understand because over 90% of the world's unfrozen fresh water is stored underground inside these aquifers. But as we have seen with our own personal model aquifer, depending on the type, aquifers can have different abilities when filtering water. Clean water in aquifers start with clean water on the surface. Much like our models, some aquifers are not very efficient when it comes to actually sanitizing the water, so preventing contaminated water from entering aquifers is an important precaution. This requires healthy landscape, healthy soil, and minimizing pollutants on the surface such as oil spills, pesticides, and other contaminants. As a reminder, this video is for educational purposes only and not for treating your drinking water. Drinking improperly treated water can be dangerous to your health, and we are not showing you an approved method to purify water for human consumption. I hope you had fun learning about the aquifer process today. These ideas can be further discussed when contemplating how aquifer hydrology supports clean water availability all over the world. What are some actions that people can take to make sure that our aquifers continue to function properly? We here at the Edwards Aquifer Research and Data Center are passionate about our water systems, and we are glad to know you are too. If you enjoyed this video, please subscribe to our channel, give us a thumbs up below, and share with your friends. If you have any questions about the activity, please email us at eardc_education@txstate.edu. Thank you for joining us on Aquatic Science Adventures. Have a wet and wild day.